Good morning, students. My name is Architect Amitina. I am Assistant Professor at School of Architecture at Galgotia University. Today we'll be studying about reinforced concrete cement or RCC as building material. So before starting, it is very important to understand that what a student should be aware of the previous knowledge. The student should be aware of RCC as a building material, which is the basic information, and the different components of RCC. Objective of this lecture are student will be able to understand the basic information in RCC frame structure, like what are RCC frame structures, what are the different components of RCC frame structures, the making of RCC. There are some grades of RCC, there are some ratios that are to be used before the making of RCC, and the advantages and uses of RCC. So let us now begin the lecture with the introduction of RCC. RCC or reinforced cement concrete is a type of concrete that contains embedded steel bars or plates or fibers that strengthen the material. So the reinforced cement concrete is a kind of a plain cement concrete. The difference is in a plain cement concrete we don't use the steel bars or the plates or the fibers. So we introduce the steel bars and plates or fibers to make the cement concrete more strong. The capacity to carry load by these material is magnified, and because of this, RCC is used extensively in all the types of construction. In fact, it has become the most common utilized construction material among all the construction typologies. Reinforced material are embedded in the concrete in such a way that these two materials resist applied forces together. The steel bars or the fibers or the plates and the concrete material, they both are embedded together so that they resist the applied forces together. The compressive strength of concrete and the tensile strength of steel form a strong bond to resist these stresses over the long span. Plain concrete is not suitable for most construction, as I've said, most construction projects, because it cannot easily withstand the load or the stresses created by the vibration, wind or other forces, the dead load and the live load. Moving further to the introduction part, it's a very versatile construction material which is obtained by hardening the mixture of cement, sand, gravel in a proper ratio and water in well proportioned quantities, which we will discussing further in this lecture. As we all are aware that concrete has a very high compressive strength but low in tensile strength. Wherever tensile forces are involved, like in slabs or beams, it is recommended not to use the plain concrete. So adding steel to the concrete is a solution. As we know, it has high tensile strength and also possesses some good compressive strength also. However, the bond between concrete and the steel works well when these two are combined, called reinforcement. So when the steel bars and the concrete are embedded together, the composition is together is called as the reinforced cement concrete. After the lines, the material is known as the reinforced cement concrete. Now let us see what are the different properties of reinforced cement concrete. Why reinforced cement concrete is more advantageous over the plain cement concrete and other building materials. So when we talk about the properties or advantages of reinforced cement concrete, we are talking about a good reinforced cement concrete. So a good reinforced cement concrete should meet all the requirements, ensuring its quality and as well as the sustainability. It should be capable of withstanding compressive and tensile as well as the bending and shear forces of the building. It should provide complete insulation against the sound and the heat. Ensure durability to the structure. The structure built with RCC, which are called as the RCC frame structure, should be able to support any kind of load, the dead load and the live load. It should prevent corrosion by providing proper cover to the reinforcement. The type of concrete which we used in the reinforced cement concrete should provide a proper cover to the reinforced to avoid the corrosion in the steel. It should develop hair cracks within the permissible limit. So there is a possibility of developing a minor cracks in the reinforced cement concrete, but with the permissible limit. So when the reinforced cement concrete is fresh, a good RCC can be molded in a different shape or desired shape and size. So this video will explain you more about the importance of RCC. Reinforced cement concrete or RCC is the combination of ordinary concrete with the reinforcement. So this is done to increase its compressive as well as the tensile strength to the great extent. It's a very versatile material for modern construction, which is prepared by mixing well together in a well proportioned quantities of cement, sand, crushed rock or gravel and water. It's been used for foundation to the rooftop of buildings, in construction of highways, dams, irrigation canals, drains, and other concealers. So it's a very versatile material which is used in the construction field and a very common material as well. So purpose of reinforcement in concrete is done because as concrete is very high in compressive strength but has a very low tensile strength. So thus when only the compressive loads are acting on a concrete surface, there is no need of using the reinforcement in it. But where tensile forces are involved, for example slabs, as in beams and slabs, there are very high risk of failure when plain concrete is used. So steel, however, as we know, has a very high tensile strength. Hence, when these two, concrete and steel, are combined together, a material of construction is obtained. But this is capable of withstanding all the three types of forces likely to act upon the structure. Compressive loads, tensile strength, and the shear forces. These three are very important parts which define the building. So it has proved extremely useful and in engineering construction. The main principle in the preparation of reinforcement cement concrete is to make a structure material in which first, like the steel serves the purpose of bearing the main tensile strength, concrete bears the main compressive force. So concrete acts as a compressive and steel acts as a tensile thing. Why there are so much of advantages of reinforced cement concrete? Because there are many advantages of reinforced cement concrete. We will discuss some more advantages of reinforced concrete here. Structure made from reinforced concrete are durable. It has a high compressive strength due to concrete and has a high tensile strength due to the steel reinforcement, the steel bars, the steel frames. It is resistant to fire and other climate changes. Easily available almost anywhere in the world. Too much expertise is not used, so the labor used has not to be very skilled. Normal skilled labor can also do it. It can be molded in any form or shape. When it is not dried, it can be used in any shape. It can be used in any part of the structure, that is from foundation to the top roofing. Preparing cost is almost nil. It is more economical compared to other materials. So let's see the more advantages of RCC that we have seen in this video in a brief form. Structure made from reinforced concrete are more stable and more durable. It possesses high compressive as well as the high tensile strength. The high compressive strength is due to the concrete and the high tensile strength is due to the reinforcement in it. It is economical, it is not very expensive, and maintenance cost is almost ignorable. RCC has the least chances of buckling and rusting. It has resistance to fire, which we have seen earlier, and other climate changes. RCC structures are aesthetically up to the mark and do not require cladding. So there is no need of giving a cladding to the surface when the structure are made in the RCC. The material is available everywhere around the world and does not require expertise for working. So the transportation cost is also very important during the construction. So RCC is mostly available in anywhere around the world, and there is also an important point that the skilled labor is not required by working on it. So normal skilled labor can also work in RCC. So now, as we have earlier seen in the video, the different uses of reinforced cement concrete. So in a brief form, let's see what are the different uses of RCC. RCC, which is widely used construction material throughout the world, from foundation of the building to the rooftop of the building. Some of the major uses are listed. It is used as a structural element in beams and columns, footings, lintels, stairs, roofs, and slabs. So every part of the building in a building construction, the reinforced cement concrete can be used. It is used for precasting railway sleepers and electric poles as well. It is used for paving in airports, roads, high traffic areas. It is used for constructing various structures like water tanks, dams, bins, silos, bunkers, bridges, retaining walls, underwater structures, towers, multi-story buildings, depth docks, and harbors. So you can see everywhere, every part of the building construction, RCC can be used. So it's a very common building construction material that is used throughout the world. Now let us discuss what are the major parts of a RCC building, which are called as the reinforced cement framed building. So the reinforced concrete frame structure is usually a connecting frame of members. There are different members which are connected together, which are firmly connected together to each other. These connections are called as moment connections. There are also other types of connection which are include the hinged connections that are mostly used in the steel structure, but the concrete frame structure have moment connection in almost all the cases. So the three major parts of the building construction in RCC, as you can see in the figure, are the columns, the slab, and the beam and foundation. So now let us discuss one by one the major parts of RCC building, RCC frame structure. The first RCC frame, the first major part of RCC frame structure are the slabs. These are the plate element and carry the loads primarily by flexion. They usually carry the vertical loads under the action of horizontal loads due to a large movement of inertia. They can carry quite large wind and earthquake forces as well, and then transfer them to the beams, and then further beam transfer these forces to the foundations. The second important part of the RCC frame structure are the beams. As you can see on the figure, the highlighted red color portions are called as beams. These carry the loads from slab and also to the direct load as masonry walls and their self weight. The beam may be supported on the other beams or may be supported by column, forming an integrated part of the frame. So this frame, which is made by the beams, columns, and slab, are the frame structure. These are primarily the flexure members. The third important major part of the RCC frame buildings are the columns. As you can see in the figure, the highlighted red color part of the building are the columns. They carry the load from the beam and the slab to the foundation. These are the vertical members carrying load from the beams and from upper columns. The load carried may be axial or eccentric. Columns are the most important when compared with the beams and slab. This is because if one beam fails, it will be a local failure of one floor. But if column fails, it can lead to the collapse of the whole structure. So these columns are very important and the most important part of the RCC frame structure. The fourth and the last major part of the RCC frame structure are the foundations. So the foundations are the load transmitting member. They transmit the load to the earth. From the column and from the beam and from the other structure members. Foundations transfer the load to the earth. These are the load transmitting members. The load from the columns and walls are transmitted to the solid ground through the foundations. So these act like a transmitting member, transmitting the load, any kind of load, the dead load, the live load, the weight of the walls, the weight of the upper columns, the whole structure are defined. The whole load of the building are transmitted from the foundation to the earth. Now let us discuss the making of RCC, how the RCC are defined with different typologies of construction work and with different cement is to sand ratio. So to prepare a simple construction work, it is important to know the proportion of sand, gravel, cement, and how to prepare the mortar concrete ratio. So every type of work has a different type of proportion, the cement to sand ratio. So while we are constructing a typology of work related to water tanks, the ratio should be around 1:3. While we are doing the brickwork, the ratio should be around 1:6. While we are doing the step construction in a stony form, the proportion should be around 1:7, and in the finishing work, the ratio should be around 1:2. So while we are doing the wall construction, the proportion of cement, sand and gravel should be around 1:3:6. For making foundation, which are very important part of the building construction, it should be around 1:3:6 or 1:3:5, depending upon the typology of work and load. While we are doing the RCC column and beams, the ratio should be around 1:2:4. And while we are doing the related work related to the plumbing, the hand pump foundation, the ratio should be around 1:2:4. So there are different grades of reinforced cement concrete that are used in a different typology of work. The grade which are described in the form of M100, M15 or M150, M20 or M200, M25 or M250. Are these numbers depict the expected compressive strength in a limited time of 28 days. So when we refer the following concrete code table, knowing this table will help you in deciding the proportion of cement, sand and gravel in RCC. So when we use the concrete grade of M100, the proportion of cement is to sand is to stone is 1:3:6. And the expected compressive strength that comes out after 28 days, it should be around 100 kg per centimeter square. M15 or M150, the proportion of cement is to sand is to stone is 1:2:4, and expected compressive strength in 28 days is around 150 kg per centimeter square. For M20 or M200, the ratio is around 1:1.5:3. Expected compressive strength in 28 days comes out to be 200 kg per centimeter square. So as we are increasing the grade, it is seen that the expected compressive strength increases. So that depends upon what kind of construction you are doing, where that part of RCC is used, how much is the load. We change the concrete grade accordingly. In the last, the M25 or M250, the proportion of cement is to sand is to stone is around 1:1:2, and the expected compressive strength in 28 days comes out to be 250 kg per centimeter square. So now let us conclude the lecture in the following points. RCC or reinforced cement concrete is strengthening of cement concrete, the plain cement concrete, by adding mild steel bars in it. There are two types of steel bars, round and torsion. The various elements of RCC construction are foundation, which we have seen earlier, beams, columns and slab. Foundation are the major and the most important part. These can be prepared by mixing a right proportion of cement, sand, gravel with water and steel bars. To increase the tensile strength, Mild steel are used in cement concrete, thereby reinforcement. These steel bars are plain in surface or round sections. Diameter should be around 6 to 50 mm. These rods are manufactured in long lengths and can be cut quickly and can be bent easily without damage. Steel bar used in cement concrete provide good strength to the structure. It has a high compressive strength because of the concrete and has a high tensile strength because of the reinforcement in it. It is resistant to fire and other climate changes, easily available anywhere in the world. Too much expertise is not required for working on it. Normal skilled labor can also do it. It can be molded in any form or shape according to the design. It can be used in any part of the structure from foundation to the roof topping. Repairing cost is almost nil. It is most economical compared to the other building materials. So these are the references for your investment of knowledge of reinforced cement concrete. You can go through these references and understand more about the importance of reinforced cement concrete as a building material. So before ending, I am putting 3 questions before you as an assignment. My first question is, what makes reinforced cement concrete as a most common and economical building material in construction field? My second question is, what are the differences between the reinforced cement concrete and the plain cement concrete? And my third question is, what are the different components of a reinforced cement concrete? So these 3 questions are your assignment. In the next lecture, we will be discussing about the analytical part of the reinforced cement concrete frame structure. Thank you for your time. Thank you.